Yeah, great talk, and it's also really encouraging to see we're getting this level of detail coming in. It seems like the quality of data is coming in really well. A couple slides ago, I started getting confused a little bit as to the many different modes of data collection schemes you have.
Sure.
I was really interested in that apportionment slide.
Yeah.
Where you showed half of the, half the emissions were from cars. How did they collect that data? Was that a bottom-up version, or was that the spiral aircraft?
Yeah. It's hard to describe this succinctly. So I compared my model to the NASA observations, and I spent a long time doing that. And then once I did that, it took about a year of my time to just make sure that the model was doing correctly. So I had to adjust a few things in the model. I had to adjust the emissions that were going into the model. I had to adjust some of the chemistry in the model. And I had to, both, let's see, there's one other thing. Yeah, there are two different big chemistry changes.
So you're using several techniques.
So I'm using several techniques to enhance, to improve the model, and then once I improve the model, then the model has the capability of then tagging certain pollutants and tracking them over time. Using, I won't get into that technique, but it's fairly complicated. Yeah. Any questions?
This was a terrific talk. I'm just wondering how the budget is, are there issues around funding of these satellites, and who supports it, and what do you think the future is?
Yeah, so I didn't say this explicitly, but actually the main satellite that's so great is actually an ESA satellite, European Space Agency. And so that's actually most of the satellite data I showed today was from a European satellite. That's why the Netherlands released the product. The U.S. the last satellite that the U.S. launched for air quality was in 2004. For this particular type of air quality was in 2004. It's called the ozone monitoring instrument. And there hasn't been an air quality satellite since then that measures at quite the urban scale resolution. There's a lot of other, there's plenty of NASA satellites, but when it comes to observing this particular type of air pollution, there hasn't been one launched in 15 years or so. With that said, there's now this new one that's going to be launched in 2 years or so, 2022, that will be focused just on North America. And that's called Tempo. So there's been a lot of funding related to that, but yes, there's some issues in getting funding. But NASA will still funding air quality research in general, but in terms of new satellites, there's really just one that's coming up. Actually, there's another. There's two. There's the one for trace gases, the gases that I'm showing, and there's also another one that's going to be launched by NASA Jet Propulsion Laboratory that's looking at that particular matter. That's called Maya. And I think that's also in the 5-year time frame. It's 2 to 3. I don't know exactly years. 2022 also. Okay.
I'm guessing, because you said that the weather issues in the clouds, there are probably areas of the country that are disproportionately affected by that. Like, you think of Seattle as being more cloudy. Would the new satellite with the more frequent measurements take care of some of that issue? Yes.
Yes, for sure. You're absolutely right that air pollution is really this meteorology and emissions issue where there's some locations, if it just rains a lot, for example Seattle, they're going to have good air quality pretty much any day it's going to rain. If the air becomes stagnant and sunny, then they're going to have better air quality. If it's raining for a whole week straight, the satellite, no matter when the satellite is observing, it won't get a proper measurement. But as long as there's some peaks in the clouds, you're going to get something. Some data. Sure.
So your career is really interesting because you went from atmospheric sciences to kind of more on the health side, but everyone here is in the public health side and might be interested in avenue for sciences. So what kind of ideas or ways do you think suggestions you would have for folks to get involved if they are interested in this?
Well, there's.
Take a lot of math.
Yes,
Physics.
there's I mean, NASA is really close. NASA Goddard Space Flight Center is pretty close in Greenbelt, Maryland. So a lot of our colleagues work there. So there are internship programs there. There's lots of summer opportunities to work there. There's also what's called the SARP. I have no idea what that stands for, but you can actually fly in the aircraft and make measurements. So there's lots of, and NASA's always looking for people to intern there and help them analyze their data. So in lieu of taking classes, I would recommend, extra classes. I mean, certainly that's the easy answer, just take more classes on University of Maryland, you can take classes there. In lieu of that, I would say getting an internship at NASA, or NOAA. NOAA also needs researchers, which is in Silver Spring and College Park. So.
We have had students do their practicums, by the way, at both NASA and NOAA. And one of them, I believe, works at NOAA right now.
I love it. It's amazing. Congratulations. Your model is just to be used in US, or you can use in other countries? Because you said that you put the chemistry and everything.
Yeah, so that's a good point. So the model that I use is really dependent on the emissions that are input into the model, and certainly some countries have better emissions estimates than others. So the US probably has the best emissions estimates of any country globally, so it's easiest to run my model for the United States. If I were to run it for a different country, it can be done. It can certainly be done, but getting emissions into the model is usually the hardest part. And also just funding. A lot of my funding comes from sources that are looking at US air quality, but if we have a funder, actually, I mean, we do have funders that are looking at international air pollution. It can be done.
And we actually do have a global chemical transport model running on our supercomputer here at GW, so we can do these types of analysis globally.
Yeah.
Any other questions?
Okay, thank you very much.